Okay, so in our last class, we had discussed about the overview on the infrastructure as code, ISC, and overview on the Terraform, what is Terraform and all. And we saw how to install the Terraform and what is the provider block, what is the resource block, and how we'll use the different providers. Okay, how we use the codes, how we use documentations of those providers, and how we can find the resources and which resource block we'll use. So if we go to our previous demo, whatever we have done in this file, we can see here, we have this ec2.tf file, right? So let's do cat here. We have this ec2.tf file. So here you can see we have two blocks we have provided. One is the provider block and the other one is the resource block. So remember guys, whenever you go for the interviews or any interview persons, they'll ask, they might ask you on the block, they may ask you what are the resource blocks. And in the resource block, what is the first, the parameter, and the second, what is the second parameter? So here is the resource block, and the resource block, what resource type of resource you are going to create. The type of resource, this is the type of resource you are going to create, the resource name, and this is the name of the resource which you are going to create. And this name is not something that the service name or what. This is the resource block name. This is the resource of this AWS underscore instance. Resource name of the AWS underscore instance. Okay. Now, yesterday also we saw how we can use this provider block, region, and the secret key access key, which is very open and everyone can see this code. But we don't want this code to be visible, right? We have to hide this code. So today in this class, we'll discuss about more on the provider block. What are the different type of providers available, and what are the resource blocks, and how we can use more efficiently the resource block with different options. Okay, so if we go to the provider, because I'm just going you in a way where you can understand clearly what is going on, right? How you are going to use these blocks efficiently. Also, how you can use all these resource blocks with the required parameters or the required arguments, whatever is required, right? So if I go to the resource or go to the provider block here, right? This is the resource page, right? The registry. And if I go to the, which one? Yeah. Okay, this is also the resource one. Let's go to the providers here. And I'll show you how we can use different providers and how we can hide those things. Okay. So if you go to this documentations here, here it gives the AWS provider supports assuming an IAM role, either in the provider configuration block parameter, assume role, or in a named profile. We'll see how we can use the assume role, that assume STS service, assume role in the Terraform to access the services in AWS, right? So this we'll see in later classes. But now what happens, the credentials can be provided by adding an AWS key or secret key parameters and optionally token to the AWS provider block, like what we did in the plain text file. And this is not the ideal way to provide it. So for the basic demo, I had provided it. So we have to hide this one. Now, so where can we configure these things? So other settings, if you see here, it is clearly given in this page and documentations, okay? We can do the profile setting, you know how to do the profile setting. We can add this in the shared config file, shared credentials file. So here is the environment variables, which is required to be added in the configurations file or the profile file. What is the credentials variable name? This is the variable, and these are the inbuilt variables. If you change anything, it will not work. Okay, so you have to be specified the exact parameter, exact credential, exact variables. Okay, so if you see here, you can use this export commands to use this one automatically, or you can add into the AWS profile. Now, if you guys have seen this one before, when whoever worked with AWS, right? AWS CLI, what do we do, guys? We just configure the AWS credentials, right? That is the ideal way to do. The other way around is, this is the very good way to do, is to check this shared config file and keep all your configurations file in a hidden directory. You, based on your settings, based on your rules and regulations or policies being provided by your company, you have to get and do the setups. Now, this is the shared credentials files. All the credentials files, it will be put into the here. And when you put this credentials file, you have to add these parameters. You have to add these parameters there. Okay, now let me show you how we can do these configurations. Okay, if I go here, so I'll just show you one configurations by using the AWS CLI. Okay, and to use this one, because as we are dealing with the AWS CLI, what we have to do, we have to configure the things in that machine where your Terraform is being installed and you are going to execute the Terraform. Okay, now if I do here AWS version, let me check what AWS version is installed on my laptop. So it's version. So this is the AWS CLI version is installed in my. So if I see here, AWS CLI is installed. Okay, and for you guys, whoever have not ideas on AWS CLI, you can just go there in the AWS page and search for how to install this AWS CLI. I already have, I think, given how to install this AWS CLI. We have these AWS CLI commands, okay? And we can easily find, okay, this is not the one. Let me just go to the AWS CLI. AWS CLI, okay, latest version. Better to install the latest version, okay. So you just go to their official site where you can install and pending updated latest versions and whatever you want. Just go ahead, download the AWS CLI. Here is the complete installations process for the different operating systems like Linux, Mac OS, and Windows. Okay, if you're using Windows, you have to just execute this on the text. Okay, now what you have to do, you have to use this command line. What you have to do, you have to use this Windows, or if you want to use this Mac OS, you have to just follow the procedure here. Okay, so it's up to you. I'll just ping this one in the chat where you can just use and keep it handy, bookmark it in your browser so that you can follow whenever it is required. Okay, so install the AWS CLI. Once you install this AWS CLI, you'll find whatever the things installed. Okay, now, if we see this particular file, we have this access key and secret key added, right? Now, what I have to do, let me configure this in my local machine. So what I have to do, I have to simply use AWS. Once you install AWS CLI, you have to use the command called AWS. Okay, now configure, hit enter. So it will ask you the access key ID. The access key ID, and this access key ID, which you already have downloaded the CSV file, you can keep it there and just get the access key ID and put it here. So I have already this access key here. So let me copy from here, put it, hit enter, and it will ask for secret access key, right? So if I go here, let's copy this particular portion, and okay. Now it will ask for the default region. Okay, let's get the region bit there, up south. 1. Hit enter. Format none. That's okay. Now I configured this AWS credentials on my machine. Now, if I just open this EC2 file, let's delete the credentials, whatever is being set up. I don't need these credentials anymore visible here. Just remove this one. Just remove this one. And what I'll do, let's save this file. Okay. Save this file. And if I execute this one, what will happen, guys? Okay. Except Jyoti, can anyone tell I modify something in my Terraform file? And what is the command to execute first? In our status class.
Initial and apply. Initiate, you have to do the initial and apply.
Okay. It's
Terraform init.
No.
You can validate it. If not, directly run the plan.
Yes. So we can directly run the plan. So why we don't need init again? We already have initiated yesterday, right? So same folder I'm working. So we don't have to initiate it again. So if you're creating a new folder and you're creating a new project, you're creating a new automations, you're writing a new file, that time you have to initiate it. So what will happen in initialization phase? What will happen in the initialization phase?
It will download the required Terraform modules.
Exactly, required Terraform plugins, AWS plugins, and then the required plugins, modules, whatever is required for the that particular Terraform automations to run, it will download and then execute. Okay, as we already have initiated it by using Terraform init, we don't need it to do it again. So we just a second, guys. Okay, so what we can do now, if I just hit Terraform plan, first we have to execute Terraform plan. If you don't want to use plan also, that's fine. You can directly use apply. But before applying anything, it's better to do the planning to make sure whatever things you are going to achieve based on your requirement is up to date, right? And it's correct and accurate. Based on that, then you will apply it, right? So hit plan. So everything is correct. Now it's asking us to use Terraform apply now. Now we have 1 to add, 0 to destroy. So what we can do now, Terraform apply. Good. Yes. Now it will directly create the instances for us. Now you saw how we can set up the credentials locally and then execute it. Now all the access keys and secret keys are no more visible, right? We have removed from the file itself. Okay, now it's clear, guys. Now it is created, right? So let me go here and check. See, it started running. But here, if you see here, we have not given a name to it. We have not given a name to it, right? So what you can see here, we have the file, and based on the instance type, we have provided T2 micro here. Okay, now if I just go here and check key name also missing. Key name also missing. Now, as we don't have a certificate attached to it, as we don't have a key added to the server, we cannot able to access it. Also, if you see here the security, it will have the default, security group, and this default security group will have the default roles attached. Okay, now okay, sorry guys. Now, if you just refresh it, we'll find this, it's running now. Now, let's do some changes to it. Okay, before doing it, let's understand more on this particular Terraform details. Okay, how can do that? Now, we saw about this resources, you know, what is the resource block and all, and what is resource exactly and how we can get it. As I said, resources are the most important element in the Terraform language. Each resource block describes one or more infrastructure object. Whatever service, whatever object you want to create from the AWS or from the infrastructure, you have to specify in the resource block. Remember, that is the basic point. Now, we have seen here in the provider block, we have given a particular version, right? Particular version. So how we'll change this version as per our requirement? That is most important. That is most important. Okay. Now, if you see the newer version update from 0.13 version onwards, Terraform requires explicit source information for any providers that are not HashiCorp maintained. What is, guys, what is HashiCorp maintained and what is not HashiCorp maintained? Right? If I go to this providers block, right? If I go to this provider things, where it is? Providers. Okay, if I go to the providers here, right? Let's go to the providers. And here we have official, partner, and community. So if I go and check any of this particular, and if it's official, you can see maintained and created by HashiCorp. This is maintained by HashiCorp. Okay, so if I go to other service providers, if I go to, so these are HashiCorp's, these things are HashiCorp. If you see here, view more, we'll have multiple providers which is maintained by HashiCorp. That is what it is written here. If the providers is maintained by HashiCorp, if you simply give provider block without specifying the Terraform required provider, it will work. That means if I just open this particular file and if I remove this one, still it will work. Based on the provider we use it, it will download this AWS plugin and work because it is the native or maintained by Terraform. That's why we don't explicitly require this button. But in the newer version, starting from 0.13 version, it is now recommended to use this Terraform required provider, whatever you want, and then use it. So very clear, guys.
So Ranjit, so consider that in the production, we may be having old codes, right?
Exactly, yeah.
So in that case, we have to start adding it if we upgrade our Terraform to 1.3?
Yes, that is very good question. Then how you do that? Suppose in your very old codes, which will be written long back, and definitely they will not have this particular code. They will have starting from providers. Then how will you add this? If you add this portion, it will not impact until unless you provide the accurate version. We'll see how this version can be used in a different way. Suppose you are using in your previous code or old code, you are using 2.34 version, 2.34 version. What you have to do, if you want to add this, you can simply add version 2.3. That's why it is also mentioned here. It is for both maintained and non-HashiCorp maintained. That means if you are already working the HashiCorp maintained plugin or provider, you don't have to add it. It will work. It will work. But in the newer versions, they are giving options. You may or may not add. So what happens? It's here explicit source informations for any provider that are not HashiCorp maintained using a new syntax in the required providers nested block inside the Terraform configuration. So which are not HashiCorp maintained, you have to mandatorily provide this particular required providers. If you're already using AWS, then it is not required to add it. If you add it also, it's good. Okay. Now, let's check about the versions and all. How we'll use the different kind of versions, right? Before going to that, let me just we talk about this. Okay, let's talk about this versioning first. What is this provider versioning and why it is so critical and why it is so useful? Basically, why it is so critical. If you're working on any automations and if you're not sure about the versioning, what is the previous version and whatever the current version or what you are going to upgrade it and what will be the impact. If you don't understand, then it will be a big challenge and big problem for you to do the infrastructure setup, right? So here it happens, the provider versioning, the provider plugins are released separately from Terraform itself. They have different set of versions numbers. So here we can set up the versions explicitly. Like if you see here, the version we have provided here as equal to 4.52, right? And if you want particular to provide a version which is equal or greater than this particular versions. So what you have to do, you have to specify this tilde mark greater than, suppose this version is 3.0. Any version within the range, this is the range, within the range 3.x version. So if you see this one, normally you'll be thinking why we need a range, right? The range is required, suppose your application. Think about the scenario. I always tell you, whatever thing you are doing, you should know what you are doing and what will be the use of that, right? If you're going to use few applications which are built from suppose 2.0 to 2.9, in between you have few applications. In between you have few servers, you have few automations have been done and few files have been created. And if you're going to do these automations by using the range tilde greater than 2.0, what will happen? The range with the 2.0, it will be all the infrastructures will be updated within that range. Normally, what happens if you have to specify particular version? Why we need these particular versions? Normally what happens in your company, if you're doing automations, we work on particular version. So it is always recommended to use the exact version which is being used. Okay, so particular version which is recommended to use. We have to always use. So what happens if you see here, for production use, we constrain the acceptable provider version via configuration to ensure that new versions with breaking changes will not be automatically installed. If you do some changes to the version range, it may impact the server configurations. So be careful whenever you are working on the versioning part. Also, you might have noticed, right, when you initialize something, right? When we initialized something, we got some hidden file. See, if I do ls-la, we have some hidden files here. What is this hidden file? This is a log file. We'll have more details in the log file, but basically I'll tell you what is this log file, and we'll have a complete session on the log file also, how will this log file and state file also. Okay, so what is this log file? If I just open, this is a file, okay? This is a simple file. If I just open this file, let's see. See guys, what it contains, this log file. This is file maintained automatically by Terraform init. When you initialize the folder, initialize the project, it will create this Terraform log file. Okay. So this Terraform log file based on the provider block, in the file, it will create this log file. And in the provider block, we had given the version 4.52. And it has created a hash which will help you to lock any version upgradations accidentally. It will not allow you to upgrade the versions accidentally. What you have to do, if suppose there is a requirement to upgrade, then what you have to do, you have to simply delete this particular log file, then change the version, then it will work. Okay. Now, this is the usage of this log file, guys. Now, this is the basic usage I told you. I will again the advanced locking mechanism and see how we can use that one in our upcoming classes. So remember, whenever you initialize, a log file will be created, and it will ensure you that it not automatically or accidentally upgrade the versions in the Terraform. Okay, that is for used. Now, if I go here, okay, now this is what the versioning meaning. Now let's go to some other details to understand. We saw some things in the destroy. What is this Terraform destroy?
Sorry, before going to that, so we have this TF file, right? So in the TF file, if we change the word something else and run plan, will it work? Because it may need again, right?
One second. I'm coming back. One second. Yeah, sorry, what you were asking?
So now in our TF file, if we change the version and run a plan, it will not work, right?
No,
because
it will not. It will not
may
work.
Need another init.
Yes, we have to do another init. Before doing another init, we have to delete this log file.
So what is the error it will throw? How we can make out that we need to remove the log file?
Okay. Let's do the demo. Yes, that's good. Let's do the demo. So before that, let me destroy first the Terraform, and we'll create it from the scratch from the beginning. Terraform destroy.
And if we have created this resource through multiple TF files, can we explicitly destroy only using that particular TF file? Is it allowed?
Yes, that also we can do. But that is where we'll see that using the alias, okay? We'll see how we can do in the provider blocks. We have to multiple things, right? We have to see by using the aliases, how we can do that particular resources to delete. We'll see everything we'll cover, yeah?
Because here, if you delete, everything will go. But if you want to selectively delete,
yes, we have to be selected whatever, because your resource file may contain multiple resources, right? Correct. In a block, multiple resources. But how, if you want to delete particular resource, how you delete? By using the aliases, and we'll see this in our upcoming slides, okay?
Using one TF, we may create VPC, EC2, everything, but only if you want to delete EC2.
Even not in the single TF file, even in that folder, if you have created multiple TF file, also on the multiple TF files also, see, the segmentic and the segregations of the TF file is most important. The segregation part I'll show you. We never keep everything in one TF file, okay? We have to segregate based on the resources, based on the requirement. We have to segregate. Even though you segregate it, everything after segregation also, if you keep it in the same folder and if you use destroy, everything, whatever there are multiple TF files, everything will be destroyed. So how we to be specific? By using the target, while executing the destroy command, you have to specify the target parameter, and then you have to pass in the aliases and how can delete it. I'll show you everything, don't worry, okay? And this is most important, guys, okay?
So you meant to say when we're going to create any resource or application, we need to have different kinds of folder, correct? Or
no, you understood wrongly. Not different type of folder, same folder with different file, TF file. Suppose we have, the requirement, let me tell you small requirement. Suppose my requirement, I have to create one AWS user, and I have to create one server. I have to create one S3 bucket, and I have to create one VPC, suppose, or I have to create a subnet. What I can do, I can create a file specifically named as ec2.tf, which will be specifically being written. All the EC2 server configurations will be there. Server resource block will be there. And in S3, I'll create another file called S3 mybucket.tf. There will be the bucket information, bucket creation resource block will be there. And I'll create another IAM user.tf where I'll create the user. I'll put the resource block, IAM resource block there. So suppose these three, then all three you have to put in the same folder. In this same folder, we have to, I'll show you, we'll have all these examples, everything I'll put it, okay? Not the separated folder, that is different, that is wrong. You don't have to do in the separate folder, and each folder you have to create and you have to initialize it.
Yeah, I thought.
You don't have to do that. No. So that's good questions. All the questions you have to, guys, anything coming to your mind, just ask me, or anyone also being familiar with that, they can also answer. So let's make it very interactive classes so that everyone can share their thoughts and we can, we'll learn together, okay? Good. So what do you say here? Okay, I destroyed. So let me check the versions. Okay, we have the log file. Let's modify the provider block with a different version. Okay, with a different version. So what I'll do here, let's we edit this file. Suppose I'll use the version 5.0. Suppose.
This version is nothing but the AWS based version, right? This one?
The plugin version. Wait, I'll show you again. The plugin version. This AWS plugin version. AWS ASIC of AWS plugin version. Terraform AWS plugin. Okay. It's not the Terraform version. It's a provider version. Okay. So if you go to this provider, right? If you go to this AWS provider, you can see here the version 4.52. This is the version of this particular plugin. Which version of plugin you are going to use. And if you see one, we have multiple versions, 4.50, 4.52, and all these versions. If you see all versions, you'll see whatever the versions you are working, everything will be there. Okay, so these are the plugin versions.
When we change the version, normally the syntax may also change, right? So that's
Exactly.
better to follow everything.
Exactly. So based on the version, the syntax might change because they're upgrading their tools, right? They're upgrading their plugins. Suppose if you want to use 4.27, so you just select this 4.27. Based on that, you just go for the documentation here. Go to the documentation, and based on that, you'll get the code. See, you are viewing the documentation for 4.27. This is how you have to use cleverly the documentations. It's very, very, very useful. Okay, then so, you'll get the code accordingly.
Yeah, and so in the existing old code, if we want to upgrade the version to 4.52, just by changing the provider block, it may not work. The syntax also we have to confirm.
Exactly.
When we are updating old code. Okay.
Exactly. So suppose what happens, you have 4.27, or suppose you have 3.0 versions code you have written, and you want to upgrade to the newer version 4.52. Sometimes what happens for 3.0, whatever the parameters and the resources parameters will be there, that might not be there. They might have changed something. Then you have to upgrade it accordingly. So it is the simple ways, right? Whenever we do any upgradations in your company, in your organization, anything, you make sure that everything is up to date based on the requirement and based on the things, whatever new changes be there and new things are there. If you're downgrading or upgrading, it's up to you. And you have to definitely change the code based on the versions parameters available. Okay. So good guys, asking for these questions, and everyone should know how we are working with things. Okay. Any other questions, guys? No? Okay, we can proceed.
Hi, Ranjit.
Yeah, sure.
Ranjit, can we change the version without destroying it?
It will not allow. It will not allow. Okay, we'll do that one demo also, one project, one run also. Okay. Okay, let me just do the changes. Let me save it. Okay, let me save it. It will forcefully also, we can do that also. I'll show you how we can, once we manage the state file is there, right? Once we cover the state file things, then you can also understand how you can do that. Okay. We have to, that state file is very important. That's why I've kept it. After this, I'll talk about the state file. State file management is most important in Terraform. Okay. And that will take one complete class on state files. Okay. So what I did, I just updated to the EC2, and I did not delete this log file. Log file is there. Okay. And this log file, if you just open it, it is contains still the version, still the 4.52 version, but in our Terraform file has downgraded to 4.50, right? Now let's execute and see whether it is working or not. So what I can do, Terraform, let's do the plan. But, okay, see, if I directly do the plan, what it did, it first checked the configuration file. We have done 4.50, but the log file is contained, the log file is contained 4.52. It did not allow, it shows error. So what happens? Provider requirements cannot be satisfied by logged dependencies. So it first checked the log file and did not allow. So what we have to do, let's do the Terraform init, because we downgraded, we need the new plugin now. Okay, so what we have to do? We have to do Terraform init. Initializing, again, it is failed because of the log file. Because of the log file. What it says, reusing previous version of the HashiCorp from the dependency log file. Error, failed to copy available provided packages. Everything is given clearly. Now what I can do here, simply I can go, if I want to downgrade it, I can simply go and delete this particular log file. Okay. Now the log file is deleted. Then now if you want to downgrade it, simply initialize it. See, it is downloading and installing the new plugin version. The old plugin versions, not new, the 4.50 plugin. So every time you want to do some changes. That is a very good mechanism and locking mechanism being provided by the Terraform. Okay, it's very good one. So you have to be careful and you have to work. And if you suppose that if you don't know and if you upgrade or downgrade something, it may cause some problem, right? So that's why it is locking. Now, if I do initialize, it will download that specific plugin and do the required setups. Okay, it's done successfully initialized. Now I'm not executing the things. Okay, so what is it? Okay, someone was, sorry, I could not get the name. I was asking whether we cannot change the versions while the server is running without destroying it. Without destroying it. So what will happen? We are creating the same resource, but with a different Terraform plugin version. But our resources is already being there. If you execute the same thing, it will say it's already running. It will not check the version of the EC2 server or server instances, right? It will just checking the plugins and versions of that required plugin and required Terraform file. Okay, it will throw error. It will not allow you to recreate the same server again. Okay, so for that, we have to work on the state file. We have to work on the state file. Okay, let's move on further and to understand more on the other things. Okay, before that, let's talk about the destroy. Okay, here you are asking about how particular service to destroy. Here I'm going to tell you, right? So Terraform destroy, what it does, it destroy all the resources created within the folder, not only within the file, within the folder. Okay, suppose you have this EC2 TF here, one, and it will have, suppose, another im.tf, imservice.tf or user.tf or any other TF files. Anything available in this folder, everything will be destroyed. So how you want to be specific? Let's go ahead and do this demo again. Okay, so before that, before coming to the destroy part, let me tell you about another provider which is very useful for you, which is the GitHub provider. How you'll use this GitHub provider? The same way, just go to the provider block here. Okay, and in this provider block, search for the GitHub. I think we'll have this GitHub somewhere here, or else if you don't find, just search for the GitHub plugin, GitHub provider. Okay, so here we have the GitHub providers are there. GitHub integrations, GitHub resource. Okay, we'll have GitHub has GitHub servers, partner providers. Where is the GitHub? Let's do the see all. Okay, so this is, I believe, will be the official one, GitHub by integrations. Okay, so this is a plugin which is being provided by integrations, a partner of Terraform. Okay, now let me get the code which is I have written in my particular things here. Okay, here, okay, anyway, that is the same thing, integrations being used. This is the partner here. How you'll find this one, if you see here, we have official partner community. Do you guys understand these three things? I think last class I told you. Official, which is created by Terraform itself. Terraform created and maintained by Terraform. And partner, which is created and maintained by the partner itself, partner like GitHub and other, like some company, other companies who have created that particular program, particular plugin. They have created and they are maintaining, but they are just a partner with Terraform. They have shared their plugin with Terraform to market it. And the community is like you and me, who has some knowledge on creating plugin, and a developer who have created their plugin and just adding into the community, free community, open source community, where people, if you feel that this plugin is particularly required for you, you can just get it and use that protocol. Now you understand about these 3 tiers, right? Official, partner, and community. Good. Now we have these plugins, right? GitHub. Go for this partner one, and this is a partner and certified partner. Same way how we use the documentation, and it is the version of 5.16, the latest version. Okay, the latest version. And here is provided how you use this particular code. Okay, follow these documentations and you'll find all these details. Now let me just use this particular code of mine, whatever I have created. So we'll go here and just create, suppose I'll create a file called myrepo.tf. What happens here? What I use Terraform block, Terraform block, and this Terraform block, we have this GitHub source integrations and all these things. Okay. Now let me change this one. Okay, this particular when I copied from, and this will throw errors. This is not the right double quote in Linux. Okay, this will throw error. Let me just change it. And this is the right one. Okay. Same thing I'll do for the other one. And whatever the code I'm writing here, command line VI editor, can anybody tell what it will do and what is the syntax? If you know, what is this command? This is a very useful command if you are going to use.
I think it will replace globally.
Yes. So what is it doing? It is just searching this code and replacing with this code globally. Okay. If you don't give G, only the first line will be changed. So globally means any, because there will be 1,000 lines of code, right? 1,000 lines of how you'll do it one by one. So it is used globally and it will update it. So now I updated, I changed the code here, right? All the codes have been changed. Now let's save it. Okay, so what I did here, Terraform required provider, and here you have to provide the GitHub token. You have to provide the GitHub token to do that. So what is this GitHub token and how you'll get it? How you'll get this GitHub token? I think you already know, but let me get those details. If you, for that, you should have an account with GitHub. I have accounts with this GitHub, okay? So if I go here, I'll have my repository. I have 32 repositories created in my account, okay? So how will get this particular token? If I go here, settings, okay? Go to settings. Then what I can do here, let's go to the developer setting here. Personal access token, that is called token or PAT, P-A-T, personal access tokens. And here, token classics, they have upgraded to beta, but don't use now. I have already something which is expired. Let's create a new token, classic one. And it will ask, I have activated the multi-factor authentication. So I have to provide the code from my mobile. Okay. Authentication code, I'm using one of the authenticator here. Okay, 715.
It will be a OTP kind of code will generate to the mobile?
Exactly. Yeah, it is kind of RSA token you are using, right? A 6-digit code will be generated. Similarly, one authenticator I have installed in my mobile, and that is I have integrated with the GitHub. And whenever I get access to the some modification required in my repositories required the authentication code generated in my mobile phone. Automatically every milliseconds, it will every few seconds, it will I think 10 seconds or 30 seconds, it will generate a new token. Okay. Okay. Let's do this Terraform. Something I gave a note Terraform, and what I need, I just repo some changes, whatever the things you need to give it, usually. and delete repo or something, I guess. Okay, let's generate the token. Okay, this token is generated. Let's copy and keep it handy somewhere for future reference. Okay. And there was some expiration also set up. I did not tell you that expiration, how many days, for how many days do you want that particular token to be active? 7 days, 30 days, or no expiration. If you don't want to expire this code, you can just keep it. Okay, I just copy this one and provide this one here, the token. Provide this token here. Okay, done. Let's do here. Now save this one. Name. So what I did here, same thing. I just used the provider block with the token and the resource block. I have one resource block which is having GitHub _ repository. That means I'm going to create a repository. Then how you use this GitHub, I think you know already, but let me tell you again. Okay. So if I go to the GitHub provider, we have these resources. See, we have these resources. Go here. And what do we need? We need to create a repository, right? So if I just go to GitHub repository. Okay, GitHub repository. Okay, go here and we'll see here how we can use this one. See? Okay. So this is how you have to use it. So if you see the code, I've got all these things from there itself. So the name of the repo, I'm using this GitHub _ repository resource name type of resource. What do you want to do? I'm going to create a repository and the name is Terraform example, suppose. And here the name of the repository. This Terraform example name is the nothing but the resource name. But the repository name, this name equal to this is the repository name. Okay, now here the descriptions, it's up to you. And the visibility is most important, whether you want to make it private or public. Private or public, you have to specify it. Okay, now let's save this one.
Hello, sir.
Yeah.
Can we hide the token here?
Yes, that also we can also hide a similar way to do the configuration of changes, right? If I go to the GitHub documentations in the provider block, it also has given how you set up these tokens. Token, you can create a variable and put it there. Also, you can use this. We'll see this everything in details, okay? When we complete the variable things. See, everything is given here. Okay, always follow this particular provider documentation, because see, if I go every documentations and go through that, it will take lots of time to complete the classes. So whenever I'm just giving you the ideas, where you have to find it, you have to get all the details by yourself and do the practice. Once you do the practice, it will be memorized and it will become permanently, you can memorize the things. So just do it, try how we can do it, but don't worry, this variable things, when we cover the variable part, that time we'll see how we can hide it, okay? Now let's save it. Now, if I check this particular folder, now what happens? We have two files. One is the ec2tf and another one is the myrepo.tf. Got it? So if I do Terraform, okay, now it's the question for you. I'm not telling anything. What I have to do, what command should I execute now first?
Terraform, I need first, we have to execute this command.
Why?
Because it's download the plugin of the GitHub.
Okay, the answer is not quite, it's correct, but not the way you told. It will not, you can say, because we added a new provider, we have to do the init.
Yes,
don't say like you have to download a new plugin, it will download a plugin and all. So you can say we added a new provider block, we added a new Terraform file, and for that we have to initialize it. Okay, so in this provider block, we have a different provider. For that different provider, we must have to initialize it. Yeah? Terraform init. Okay. So what will do? Already, what happens? Duplicate required provider configuration and module may have only one required configurations. EC2.tf. And my repo line. What is happening in this my repo? Here another good thing you need to understand here. What happened here, guys? Same folder cannot have multiple plugins. Okay, what we have to do? So if you see here, what error we got it here? Let's check this error first. Okay. What it says? Duplicate required provider configuration. Same folder you should not use for multiple other providers, because the Terraform will get confused which provider to be installed for what, and that it is always to be recommended to segregate all the things. The segregation is not it. I have taught you. I'll teach you in the next classes. Okay. The segregations, how we can do it. But whenever you do segregations, be specific. The segregations done by the provider's name. Suppose here we are using AWS provider in EC2TF. EC2TF we are using this one. So what we can do now here? Let's go ahead in the same folder. Let's EC2 there, but let's create another folder here. Inside that folder, another subfolder, or you can go ahead, create another folder after that. So what we can do here, I can just use something like my repo. Okay, my git repo, something like that. I just gave a name to this. I created. Let's move this file, TF file, to. Okay, let's go to this directory. And here we have this Terraform file. And here you have to do Terraform init. So these kind of things you will encounter when you do practice. Okay, you will come to know more things about the Terraform and the usage of it. Hit enter. See, as I moved it to a different folder, it downloaded the required plugins to that particular folder. So now Terraform is first what happens, how it is working. It first scans the folder for everything. It scans the folder for log files, scan the folder for state file, scan the folder for Terraform file, and check the provider block, and scan the folder for the existing providers block, plugins, and all. If it does not find anything, then it will download and install the new plugin. If it is already there, then it is getting the conflict over there. Okay. Now we have these things created. Now use Terraform plan. Terraform plan. Okay. Want to add, use Terraform, apply. Done. Yes. So what happens here? Based on the tokens and all these things you have added, it will connect to your GitHub account and will create the repository. So within few seconds, it says within 7 seconds, it created the repository, right? One added. Now, if I go to my repo here, see my new repo, Terraform, and it is private. It is private. Okay. Now, so requirement is comes to change it to public. It's not required. You should not come here and do it manually, right? What you can do, if I do the changes to the file, what will happen? See now, if I just choose my repo.tf instead of private, let me change it to public. Okay, private, I'll change it to public. Okay, so change to public. You can see visibility is now public. Okay, save it. Now let's execute this one and see what warnings, errors, or success code, anything what we are getting. What will happen? Let's first execute plan and see. What happens here? It says us 1 to change, 0 to add, 1 to change, and 0 to destroy. What is getting changed? It is getting changed from visibility, like from private to public. Okay, before changing it, let me check this state file first. I have not covered the state file yet. Don't get confused. Just understand, just see what I'm doing. But when I cover the state one, Terraform state, that is called Terraform state file. It's the extension is called t.tf state. Whenever you do initialization or plan anything, it will get, or apply, it will get created. Okay. Now let's check this one, what it contains. See, when we execute the Terraform, do the automations, once it is created, that particular resources, that particular object, everything will be get recorded into the Terraform state file. That is the one thing you, for the time being, understand, and then it will explain further. It has the version, it has the Terraform version. This is the Terraform version, which Terraform is being executed, 1.0.1, right? And if you go here, we have this private, we have this visibility is private. But we have modified the visibility in our Terraform file, but the state file is still shows the visibility is private, right? Now, let's see. Sorry, I'll apply Terraform. Apply. So, yes. What happens? It changed one. It modifying this repo and changed one. Let's go ahead and refresh this one. Now you can see here, it became public. But now go ahead and check the Terraform state file. What is the behavior of it? Just have a look, okay? So we have this Terraform state file, right? Let's do that. Now another one also is created. It's called backup automatically. We did not take any backup, right? Automatically backup. Let's see both of the files. So here it is new Terraform state file is created, that is change to public. Now other one is, let's see, check this backup files. It is having private. So what the Terraform does, whenever you execute any new apply or any apply, what it will do, it will first take the backup of the Terraform state file and then create another Terraform state file. But any questions, guys, or anything coming in your mind? Any consequences or anything it will come if you change it like this? Yeah, Jyotika.
Sir, can we track, means suppose we change here from private to public. Can we track this, means we changed, suppose someone else come and see it's changed.
Okay, see, whenever you do changes, if you see this particular node ID and all, right? And there will be some things will be there. 1 second. Who did it, repo ID, private key. And I think based on this node ID, you'll find it, but normally it will not find who have changed it. That will be done by the system administrator. You don't have, as a DevOps engineer, you don't have to worry about that. Any changes, any security changes, any user modification, or anything, that will be done by the administrator. He has to find it out in the backend, who has executed the code and all. But there is a locking mechanism. Okay, before that, yeah. Any other questions, guy, related to this? See, the thing is, it is being private, and someone, suppose I created this Terraform file is private. Someone, suppose Jyoti came and make it to public. It is kind of a security issue, right? If a private repository, someone executed the code by modifying it to make it a public, how is it possible? It is a security breach, sometimes may happen. Suppose some knowingly or unknowingly change the code, it will cause problem, right? To overcome this problem, to maintain it, we have a locking mechanism in Terraform state file itself. We have a locking mechanism on the Terraform state file that will see, because anyone cannot modify the code, it will impact the infrastructure, right? So we'll see how we can do this one by changing and all these things in the Terraform file, by locking the Terraform, how we'll maintain secure back of the state file, because state file is everything. Why it is everything? It contains all the details about the infrastructure. These all are the infrastructure information about this repo information and all. Okay. So guys, hope you understood clearly how we are working. We did lots of things today. And in our next class, we'll focus on Terraform state file and how we can see we maintain the Terraform state file locally, how we maintain in a remote area, how we'll maintain in S3 bucket, how we'll put a lock on the state file, how we'll use in the backend. Lots of things are there in Terraform state file. We'll understand all this, and we'll have to give 1 day completely to understand and work on the Terraform state file, and you will get lots of questions in the interview process from state file itself. Okay, guys, do you have any further doubt to discuss, or we can wind up this class today, and we'll meet up next Saturday and we'll discuss further. And since then, I'll just go a little faster, okay, as you understand the basic things and you understand how it is working. It is now, we'll just complete with the other resources and other type of things, okay? There are many things yet to understand on the Terraform that we'll cover in another upcoming classes.
Thank you.